Alright guys, I hope you are safe. Good morning, well, good afternoon. I've been having some issues with this software, so let's try this again. Uh, Number one, day 8, it says, what is the total area of the arrow figure? Total in math means half. So total area, so you're going to have to add the areas. Now, this arrow here, figure shaped like an arrow, there's no equation to find. I mean, formula, so you're not going to find any equation to figure this out. So you have to decompose. Just like you learned this word in science, when math, decompose means to break down. So what you can do is you can break this arrow into two figures that we do have equations for. For example, we make a straight line. We'll try to make a straight line. We can decompose into two figures. Now we have a rectangle and a triangle, and we do have equations for those on the formula chart. Our rectangle we know is area is equal to base times height, and our triangle we have on the formula chart, it says area is equal to 1/2 b times h, or the way I've told my students, area is equal to base times height, which means the same thing. So this equation here and this equation here are exactly the same. It's just the structure is a little different. Well, how do you know what two lines you're going to use as your base and height in a triangle? And the key is always to look for this little square. That means that that's a 90-degree angle. That means that by rule, my base and height, or the numbers I'm going to use here, must touch at a 90-degree angle. Hence, that's why you see this line and this line, they meet here, which means this is a right angle because that's the little square there. And so that means that this has to be my base and height. Why am I not going to use this line here, the one over here? Because if I look here, when they intersect, this line and this line, that's 90 degree. That's not a 90-degree angle. It's an acute angle. Here, same thing. There's not a 90-degree angle. That's why when you use this formula here, base times height, you must use the two lines that connect all the way down. And you divide by 2. And of course, the rectangle is a little more straightforward. Base times height. Well, let's give you the base. Okay, base times the height. There's no number here, but you know this is 2, and so that's parallel to that. That must be congruent, and so that's 2 meters also. And so base times height, figure out this one, and then figure out the triangle one, and add them to that's what this is. And then you add the two areas together and your formula. Number 2 there. Greg explained the foul line area on a high school basketball court. Area and again, the word area. And of course, we don't have it. We have this bullet style figure. There's no equation for it, so you decompose it. And as you can see, you have a rectangle here, and then you have a half circle here, or a semicircle. And so for a rectangle, we have the equation base times height. So times height. It's my equation. And for the half circle or semicircle, we don't have one on the formula chart, but we do have one for a full circle. We have this, pi times radius squared. Usually pi is 3.14, or we can use pi to be 3, approximately 3. In this case, we're going to use pi as, but that's a full circle. We want a semi-half of that. So then we're going to use pi times radius squared divided by 2. And I'll expand on this equation. I'll put pi times radius divided by 2. It doesn't mean radius times 2. It means radius times itself. Radius times radius. And so for this half circle here, so we need to know, okay, what is this measurement? What is it doing here? Well, on a circle, they either give you the radius or they give you the diameter. How do you know which one's which? Well, on a circle, the radius is always going from the center to the outside. That's the radius. But it must be from the center to the outside. And the diameter is always the line that goes all the way across to the other side, but it must touch the center. Okay. So this is called the diameter. A line that touches the outside of the circle, crosses the center, and then goes to the other side. And it has to be straight. That is your diameter. Radius is, of course, from the center to the outside, so technically radius is half of the diameter. And so if I look at this here, well, does that look like it's going all the way across? Well, what if I had the whole circle? So if I do the whole circle, I notice there that that line, this one here, is actually from the center of the circle there to the outside. So that's actually my radius. And so now you can figure out, okay, using this equation, so it means this 6, it doesn't go all the way across, it goes from the center to the outside, so that's my radius. So my radius is 6. And just for to put the same, the diameter is 12, because the diameter is double the radius. So we don't need the diameter in this problem, we just need the radius. And so what is pi? Again, pi is 3. So 3 times 6 divided by 2 gives you the answer to this half circle. And so now you can concentrate on the rectangle part of it. And the rectangle, well, you have 19 as your base. Well, what's your height then? What is this measurement here? Well, if you look at the circle, if it goes in from all the way across to the center, that's also the same as my diameter. So we didn't need the diameter for the area of the circle, but we do need to know the diameter to figure out the area of the rectangle. So now that you know that this is 12, now you can do the base times height. Once you have both answers, add them together and pick the closest one. If you don't get this, you're not going to get the exact answer because we're using pi. We're doing an approximation. So you're going to get really close to it. It can be a little more, it could be a little less. As long as it's good. Number 3. Okay. What is the total area of the shaded region figure? So again, the keyword is shaded. So that means that we can't just say, well, that looks like a big old rectangle or a square. Maybe I can just base times height is the answer. So you could, if you wanted the whole thing, but it doesn't want the area of the whole rectangle, just the shaded part. That means that this part here is unshaded. And so we don't need that part. So usually when you see this word, what is the total area? When you see the word shaded, you're going to have to subtract to get the final answer. And so we're going to have to subtract. If you do it a certain way, you're going to have to subtract. If you do it there's a few ways to do the problem. There's something you don't have to subtract. But usually, when it says shaded area, you might have to subtract. You might. It's not 100%, but you might. In this case here, they want the area of the shaded part. And if I look at the shaded part, I notice that this figure here and this figure, well, those are just rectangles. And so we do have the formula for a rectangle. And so you think that, well, I know the rectangle is just base times height divided by 2, or of course 1/2 base times height. I use this one here, base times height divided by 2. So I can just use that for this equation. I can use this triangle, base times height divided by 2. So I have one here, I have another one here with a shaded. They're congruent. So then I've got to do find the area of the triangle. I'll do the area of this triangle. together, and then I can change the bubbles, the place values. And so you do that and you'll get there. Just remember that's not the only way to do it properly. Okay, and what's the other one? Number 4. Carla discovered that she could create the perfect shaped heart by combining 2 semicircles in a square. What is the area of the heart? Semicircles. Square. We know a square, all sides are congruent. Okay. Congruent are the same. All sides are congruent or the same. Congruent or the same. So now we can decompose this figure into two semicircles and a square. A square is just a rectangle, so that's just base times height. If all sides are the same, then it's just the base and height should be the same. Now for these 2 semicircles, we don't have an area for semicircles, but we have an area for a whole circle. And that's 5 times the square. Again, you can use minus 3 and get close to an example. The radius, of course, remember, in the other problem, the radius is from the center to the outside. The diameter is another across and touches the center. In this case, we have 2 half circles, which happen to be the same because they're connected to a square. So these 2 and these 2 are the same. So technically, you can put the 2 half circles together and make 1 circle. So if you put these 2 half circles together, make the circle, make 1 full circle, then you can just use this equation. And then, of course, the equation for the square. Once you have both answers, just add them together. If your answer doesn't show up here, put the answer you get. Because I know there was a mistake on this answer key. The answer is not there. So, whatever answer you get, please just write it down. Whatever it is. Once you turn in your answer key, I'll give it your answers. Take them individually. But just remember, area of the square. Use area for a full circle because these 2 half circles make 1 full circle. And you get your answer. Hopefully this helped you. I will make another video for the other problems because I'm running out of time. It's 15 minutes max for each video. Thank you. That's it.